So you're seeing here a family of Poncelet triangles inscribed in an ellipse and circumscribing a circular caustic whose center is C. And the center is obviously the in-center, the stationary in-center of the family. Now, as I was admiring the circular locus of x36, and let me just remind everyone what x36 is. X36 is the inversive image of C, the in-center of this family, with respect to this moving circumcircle. Circumcircle is shown here as this dashed blue circle, and I'm also showing here its variable radius. We saw in other videos that its center is describing an ellipse. As I was playing with this and just taking a look at it, I decided to do another investigation. I said, let me invert the circumcircle itself with respect to the stationary in-circle. And what am I going to get? So I'm getting this green circle here. Now let's watch this green dashed circle. Its center is moving along this purple locus. But the funny thing about it is that the radius of this inversive circle is invariant over the family. So that's another very pleasing property. If I move the center of the caustic a little bit, you can see here that the inversive image of the circumcircle on the in-circle. So I'm inverting the circle with respect to this in-circle, and I'm getting this green circle. The radius of the inversive image changes with C, okay? But whichever C I choose, for example, over here, and now my x36 is a circle all the way up there. But if I choose this particular C and I run it, you can see here that the radius of the inversive image of the circumcircle does not change. For example, this other point here, it's constant, and it looks like the locus of the center is a circle, this tiny circle here. What happens if I change the aspect ratio of the ellipse? Let's make this ellipse become more like that. I can see here the radius is still being conserved. If the ellipse is fatter, conserved radius. If I move C over here, conserved radius. So I thought this was another pretty cool thing. So there's really two interesting things going on here at the same time. The fact that, number one, the inversion of C or X1, the in-center, with respect to this moving circumcircle with a moving center and a variable radius, gives me a circle. So this is phenomenon number one. That's x36 for you. Phenomenon number two is that the inversive image of circumcircle with respect to the in-circle is a circle, the green circle, of constant radius and whose center is moving along a very tiny circle here. You can see it there. All right. That's all I got. Here's table of the radii. See you on the next video.